Hi there, this is a quick tutorial for Draw2OSC, which is a Python script that I hacked together, where the idea was that I wanted an easy way to control polyphonic synths in VCV Rack, and control them by just kind of like arbitrarily sketching the automation curves. On a chart like this. So this is an example with a chord progression drawn on the chart here that controls a 5 voice polyphonic synth that's just made up of the mutable instruments, elements, physical modeling modules. So if I hit play on this, you can hear what it sounds like. So it's nice because you can draw just the slopes and the glides between notes however you want. If you want vibrato, you can just draw a squiggly line. You know, it's all you can just draw whatever. If you want to do microtonal music, you can just draw a note in between. Like if you want C half sharp, just draw a line between C and C sharp. So it's very convenient for that reason. Um, so you use it, well, you install it by, it's a Python program, so you need Python. Set up a conda environment here. So you can just clone the GitHub repo and then install from the requirements file, and then run main.py, and it'll open up this a GUI window that looks like this. And then to use the GUI, you can click or press a number from 1 to 5 on the top row. So if I hit 1 and then left click, I'll draw a red line, which is the first voice. If I hit 2, draw the second voice, and so on. And right-clicking erases. And you can draw chords and stuff by just drawing. So this was 1, voice 1. If I hit 2 now, or in 3, then I've drawn these on top of each other, and they'll play at the same time. Then to play, you hit P, which will then prompt you in the console here for how many seconds you want the run through from the beginning to the end to be. So I say like 3. It'll take 3 seconds from the beginning here to the end here. Then if I hit N, or first if I hit S, I can save it. So I can save it as just test. Then if I hit N, it'll clear it, and I hit L and type test, get it back. So that's pretty much it. The other thing is I included a GIMP template so that you can draw in GIMP or Photoshop or something else like that. Draw as separate layers these different the curves, and then export each layer. And if you do it with the same file naming convention when you load it in, then it'll load in the Photoshop drawn curves, which is easier because with GIMP or Photoshop or whatever, you can zoom in and draw really precisely and use the straight line drawing tools if you want that or whatever. So that's how I did this is I drew this in GIMP, and also in the template I included the note names along the side here. Um, it is relative pitch though, so like in this demo, it's not actually doesn't actually begin with a C chord um, because they're not tuned. So to like get absolute pitch, you'd have to tune all the voices to what you want in order to do that. As far as how the OSC module in VCV Rack works, it has to be set up so that I have it set up that the odd number channels, so there's 10 channels that I have set up here because there's 5 voices. Each voice gets a pitch CV and a gate CV. And so for each voice, the odd number is the pitch CV and the even number is the gate CV. For the pitch CV channels, I have it set so that the input voltage is from 0 to 5 because there's 5, or there can be up to 5 octaves. And then the output CV is from -2 to 3. So and that's a floating point data type. Then for the uh, even numbers, since it's the gate, it's a Boolean data type, and the input is a 0 or a 1, and then the output is a 0 or a 10. Um, so that's how that works, and I hope that this is helpful for some people, and see ya.